Today we're going to start talking about solving rational equations. So I want to go ahead and highlight my title. I'm going to highlight my two scenarios. So when I'm solving a rational equation, I have two possible scenarios in which I can encounter. I can encounter where I can create a proportion and when I cannot create a proportion. When I want to create a proportion, or if I can create a proportion, how we solve is just like we would do in any other, in any situation. We would cross multiply. We would cross multiply and then solve. If I cannot create a proportion, so let's actually back up a step. A proportion just looks like a fraction equals a fraction. 2 over x equals 5 over 17. That would be a proportion. Fraction equals fraction. If I cannot create a proportion, but I still have rational terms, so if I had like 2x over 3 plus 5 over x equals, 7 over 3. This I could not cross multiply on because I have more than fraction equal fraction. So how I would solve a problem like this is I would multiply every term by the common denominator. So you have a couple options. Both of these you learned in Algebra 1. So if you have a proportion, you can just cross multiply. Or if you don't have a proportion, you would just multiply everybody by a common denominator. So in this example that I just drafted up here, my common denominator would be 3x. So I'd multiply all three terms by 3x, and then I would get my answer. And then I would solve, I guess, to get my answer. So I'd multiply every term by a common denominator, then solve. We now have to talk about what it is to be an extraneous solution. We've seen this word before. An extraneous solution is when, let me not write actually in green, when a solution does not satisfy the original equation. So how I check for extraneous solutions is I just have to check my answers. So I'm going to come down here and I'm going to solve some of these problems. So example 1. So solve each equation and then check your answer. So because I have fraction equals fraction, I can go ahead and just cross multiply. I can multiply these together, then I can multiply these together. So when I multiply those together, I get 3 times 4x plus 5 equals 9 times x plus 1. So now I'm going to distribute, so I have 12x plus 15 equals 9x plus 9. Now I'm going to solve, so I'm going to subtract 9x to the other side, I get 3x, and I'm going to subtract 15 from 9, and I get negative 6. So then I divide, I get x equals negative 2. So now I'm going to check my answer in blue so I can see what I'm doing. So I have 3 over negative 2 plus 1 equals 9 over 4 times negative 2 plus 5. So I have 3 over negative 1, and then I have 9 over 4 times negative 2 is negative 8 plus 5. So now I have negative 3 equals 9 over negative 3. So negative 3 equals negative 3. So sure enough, that solution does work. If I come over and I look at example 2. For example 2, I need to first see if I can cross multiply. If I look at a problem like this, I can't cross multiply because it's not fraction equals fraction. So my only next option is I have to multiply by a common denominator. You could technically solve this problem in two ways. I'm going to do it this first way first, and then we'll go to the other way. So I first got to find a least common denominator. So I have x, 3, and x. What's my common denominator? 3x. So I'm going to multiply every term in this equation by that common denominator. So when I multiply this first term by my common denominator, all I have to do is like cross reducing. This will be 3 over 1. And now I cross reduce. X cancels out with x. So I'm left with 3 and 2 on top, which makes 6. And then I have nothing left on the denominator because it's just 1. Plus, if I now look at my second term, it's the same thing. It's essentially like doing 3 over 1. You cross reduce. My 3's cross out. I'm left with a 5 and an x on the numerator and a 1 on the denominator, which means it just goes away. Equals, and if I do my last one, I do over 1. My x's are going to cross out. I'm left with 7 and 3 on the top, which makes 21. 1 on the denominator, so it just makes 21 as my final outcome for that term. So now notice this is a super easy equation. I can go ahead and solve. 5x equals 15, x equals 3. So now I have to check. 2 over 3 plus 5 over 3 equals 7 over 3. I'm just plugging my answer into my original equation, which is x. So I have 2/3 plus 5/3, which makes 7/3. 7/3 equals 7/3, so sure enough, it works. Go ahead and let's try number 3. Number 3. Actually, no, I lied. Let's go back because I want to talk about how I could solve this a different way. You could have technically, and I don't think it's not going to let me erase. Oh, it does let me erase. Perfect. You could have technically solved this problem a different way. If I look at this problem, I notice this term and this term are the same, so I can move them to the other side. So I'm going to subtract 2 over x. So I now have 5 over 3 equals 5 over x, right, if I subtract fractions. So now notice it's fraction equals fraction, so I can go ahead and cross multiply. So I have 15 equals 5x, so x equals 3. So that's just another way that I could have solved it. So if you see an equation that's not a proportion where you can cross multiply, see if you can make it a proportion to cross multiply. Let's look at this next example. Is this a proportion? Yes or no? Yes. So I can go ahead and cross multiply my diagonals. So I have negative 4 times x minus 3 equals 5 times x plus 3. So I have negative 4x plus 12 equals 5x plus 15. So I'm now going to add 4x to the other side. I get 9x. I'm going to subtract 15 to the other side. I get negative 3. So x is negative 1/3. So now I got to go ahead and check. Negative 4 over negative 1/3 plus 3 equals 5 over negative 1/3 minus 3. So I noticed this problem is a complex fraction, and I don't really want to deal with that. So I'm just going to multiply the top and the bottom by a common denominator. So 3 and 3. So I have negative 12 over negative 1 plus 9, because I just distributed that inside. And then I'm going to do the same thing over here, top by 3, bottom by 3. So I have 15 over, distribute, that makes negative 1 minus 9. So now I have negative 12 over 8, and I have 15 over negative 10. If I simplify negative 12 over 8, I get negative 3 halves. And if I simplify 15 over negative 10, I get negative 3 halves. Sure enough, it works. Let's go ahead and let's try number 4. Number 4 is not a proportion, so I cannot cross multiply. So the first thing I notice is that this is backwards. So to correct that, I'm just going to take out a negative 1 and fix it. So now the negative 1 is on the top, so I'm actually going to erase it and put it on the top, which will just mean the numerator is now negative 10. So because my denominators now are the same, I could subtract them and make them a fraction. I personally don't like doing that. I would rather just multiply by the common denominator. So my common denominator here is x minus 2. So I'm going to multiply this side by x minus 2. And I'm going to multiply this whole side by x minus 2, which means x minus 2 gets distributed to every term. So if I look at this term, my x minus 2's are going to cancel out. I'm left with 5x. If I distribute x minus 2 to my first term, I have 7 times x minus 2. Plus, my x minus 2's cancel out on the second term when it gets distributed over. So I'm left with negative 10. So now I have 5x equals 7x minus 14 minus 10, because a positive and a negative make a negative. So now I have 5x equals 7x minus 24. Subtract 7x, I get negative 2x equals negative 24. So x equals 12. So now I'm going to go ahead and I'm going to check it. So I'm going to plug 5 times 12 over 12 minus 2 is equal to 7 plus 10 over 2 minus 12. 5 times 12 is 60 over 10 equals 7 plus 10 over negative 10. 60 divided by 10 is 6. 7 plus negative 1 is 6. Sure enough, it works. So I want you to go ahead and pause this video, and I want you to try example 5 on your own. When you finish example 5, unpause the video, and then you can go ahead and just check your answer from there. So if I look at this one, my common denominator is 4x, so I'm going to multiply this side by 4x, and I'm going to multiply this side by 4x. If I multiply this side by 4x, it's like I have to distribute it. Some people like to write the 4x on both sides so they can see it. So if I look at this term, my x's are going to cancel out. I'm left with 5 and 4, which makes 20. On this term here, my 4's are going to cancel out, so I'm left with 7 and x, which makes 7x. And over here, my x's are going to cancel out. I'm left with negative 36. So now if I solve, 7x equals negative 56, so x equals negative 8. If I check my answer, I have 5 over negative 8 plus 7 over 4 equals negative 9 over 8. Negative 9 over negative 8, excuse me. So now I'm going to find a common denominator for this term. It's 8, so I got to multiply the top by 2. I get 14. I'm going to go ahead and move my negative to the numerator. And this equals 9 over 8. So now I have negative 5 plus 14, which is 9 over 8, which equals 9 over 8, which sure enough works. Go ahead and do the exact same thing for example 6. Go ahead and pause this video, and then you try on your own, and then when you're finished, unpause, or obviously if you get stuck, and then I'll go over it. So if I factor this one, I have x plus 1, x minus 1. So obviously my common denominator is this. So I'm going to multiply both sides, x plus 1, x minus 1. And this whole term, x plus 1, x minus 1. So if I look at this first term, my x plus 1's are going to cancel out. I'm left with 3x and x minus 1. Now I have to distribute both of those here and both of them here. So if I distribute x plus 1, x minus 1 to x squared minus 1, they're going to cancel each other out. So I'm left with just 12. Plus 2 can't have anything crossed out because it's not a rational expression. It's a rational number. It's a whole number. So I would just do 2 times x plus 1, x minus 1. So now I'm going to go ahead and start cleaning this stuff up. So I have 3x squared minus 3x equals 12 plus 2 times x squared minus 1. I just foiled that back out. So now I have 3x squared minus 3x equals 12 plus 2x squared minus 2. So now I'm going to start moving everything to the one side. So I'm going to move 2x squared. I have x squared. Negative 3x. 12 and negative 2 make 10, but when you move it to the left, it makes negative 10. It's currently on the right. So now I'm going to factor of negative 10, that makes negative 3. Negative 5 and positive 2. So x equals 5 and x equals negative 2. Whew, okay, so now I gotta check these solutions. I'll check 5 first. 3 times 5 over 5 plus 1 has to equal 12 over 5 squared minus 1 plus 2. 3 times 5 is 15 over 6 equals 12 over 5 squared is 25 minus 1 is 24 plus 2. So 15 over 6 simplifies to 5 over 2. So now I have 1/2 plus 2. So that's going to become 4 over 2. So 5 over 2 equals 5 over 2. So that works. So now let's check -2. Make the eraser a little bigger. I'm just erasing because I'm running out of space. So now I'm going to check -2. So 3 times -2 over -2 plus 1 equals 12 over -2 squared minus 1 plus 2. So I have -6 over -1 equals 12 over 2 squared is 4 minus 1 is 3 plus 2. -6 over -1 is 6. 12 over 3 is 4. 4 plus 2 is 6. So sure enough, that also works. So I want you to go ahead and I want you to attempt the last 4 problems on your own. You can check your answers on Google Classroom if you would like, and then I can answer questions next class.